Hello everyone, I'm Eric Hux at Hux Racing, and let's just jump right into this. And I'm going to start off with giving a huge shout out to Brian at XS Motorworks, Rashad at Invoke Designs, and Anthony at XV Racing. I told those guys they could tack weld any pieces of crap together and get the motor in the position that they wanted it. Get those mock-up mounts to me in the Tesla motor, and I would produce the final mounts as well as fixtures to reproduce those. And all my measurements, these guys nailed it. Motor left to right, height, rotation, output shaft position versus the E153 or the S54 that would have came in this chassis. The package is actually higher in the chassis than what would have been stock, but that is fine with the lowered ride height. The axles are essentially going to have just a very slight downward angle. They'll always have some rearward angle, which is fine, which is what you want. I wouldn't have placed this any differently myself. Ground clearance is awesome. You can draw a line from the lowest point on the cross member to the front suspension pickup point here, and it's all within that window. Like I said, these guys nailed it, and I'm going to start building the mounts. So just follow along. We'll start with this, what I consider the front one, and get that one, get the permanent version built for it and work out from there. Thank you. Hey guys, I figured the easiest way to do this would be to time lapse it and do some narration over it without giving, that way I wouldn't give you 16 hours of sheer boredom. The first thing we're going to do is pull that front mount out. I figured it would be the easiest one to simply copy on the welding table. I really just had to get the side-to-side offset and the height offset correct since they built the mount on flanges I sent them. I knew it was already going to match my bolt patterns. So you just see me here pulling that mount piece out. Eventually, the way they kind of had, they just kind of cobbled up some stuff together to get the motor in position, but it was kind of hard to get to some of the bolts on it. You saw I was struggling with it a bit. And just like that, I'm back with the tacked up initial front mount. I'll get that into position, and then we'll get started on the rear mount. This, as far as this video goes, this mount went super quick in the video portion. The rear mount will take longer as I try to keep the motor level and square in the engine bay. You'll see me making measurements using it. I actually have some marks. This is my mock-up clip, so I have marks in the bay. I know what the center position is. Say if you were to draw a line from the front to the back of the bay, I have marks inside the bay to know what the center position is. So you'll see me use a large speed square, and I'm just checking off of those marks to the parting line on the Tesla case to make sure that I'm square in the bay. And then I have a digital level that you can't see me set the level, but I'm setting the level from the underside of that clip, and then I zero it there and then bring it out and set it up on top of the Tesla motor to ensure that everything is level, or should I say level to the clip. A little oopsie right there, my jack popped out from underneath, but it was still supported on the front and the back. Now I'm working on that rear mount. Something you probably can't make out from the video, but I didn't want to, because I knew this was going to be the first test set of mounts, I didn't want to go and make an entire lower flange out of scratch. I took our existing cross-member flange and just added a piece to it, and then I cut the two vertical pieces by hand. You know, all this stuff is just for quick fabrication to get the well, I'm not going to call these mock-ups because these are the final mounts for this car, but I will make drawings from these, and all the flanges in the future will be water jetted. There I am with the speed square, checking my marks in the bay to make sure the motor setting's square. And here I'm checking to make sure it's centered side to side. I mean, plus or minus 1/8 of an inch, 3/16. We really just want to make sure that our axles are going to be we have one length axle for the right and the left. We don't have to get two separate axle sizes made. It's pretty repetitive. You'll see I'm on top of the bay, I'm underneath the bay. I'm checking it square, pushing it to the side. I'm constantly chasing a little bit of air. The issue is because it's the set of mounts that I will be making my fixtures off of. I need to ensure that these are as close to perfect as I can get. So all the mounts in the future will have oversized holes and slots, so a guy can go ahead and square up his motor and his bay, because all these bays have tolerances. None of them are going to exactly match the engine bay that I have. But since I'm building fixtures off of these mounts, I need, all my holes are essentially the size of the bolts that are going through them. Very little play, and just really tight on tolerance. Because like I said, I'm going to be building the fixtures off of these, and then the parts forward will have slots and oversized holes and a means for making adjustments. And again, you'll probably see me check this motor with the speed square like 50 damn times, because as I said, I'm just every little bump with the jack. The clip itself is so light that when I'm trying to move the motor around with one of the floor jacks on either side, I end up shifting the clip, or something nudges it a bit. So just constantly chasing air. See that? Just once again, the digital level. Thumbs up. And there I just have a spacer. I made a spacer of the similar length of the spacing between the Tesla motor and the front of the bay down there. And I just wanted to make sure, all the measurements and that everything I was checking, that it was sitting square. And now we're on to the right mount. Probably 7 minutes in the time lapse of the front and the rear, and now it'll be another 13 minutes on the right mount. The right mount was the most complicated. Once I had the front and the rear in, there's so many pieces that were welded, so many pieces I had to fabricate together to make that right mount that, welding pushes and pulls the chromoly, and I just had to constantly tack, come back, check. Once again, I was trying to be within a 1/10 of a degree of accuracy because I'm making the fixtures from these mounts. And there's a piece of tubing. Obviously I bent that off a video, but it's a piece of 1-inch chromoly, and I put an S bend in it because I knew I was going to try to connect these two pieces together. Went to the saw, cut the extra length off. Everything looks good. Verifying what the fitment looks like underneath. Check a dozen times, tack weld once. Not sure where I went in that portion. Must have been sanding on that piece of tube. Oh, okay. The side mount on the Tesla motor, it uses 3 M8s to attach the... There was a poly mount that was attached to the side of the Tesla at that point. It used 3 M8s, but the 3 M8s aren't all at the same height. So I had to measure for 2 spacers to so when I bolted my plate down, it could sit flat. And there, went away. I tacked 2 of those pieces together. Now I'll go underneath the car there, bump that tube up against the plate at the bottom side of the motor on the right side. I'll put a marker mark on it and an indexing mark. Go back over to the welding table, tack that together, come back, set it in there. I mean, towards the end of the video, you see I actually just pulled the welder over to the clip and tack welded the final upper piece to the right mount in position. I figured I wasn't going to be able to get it close enough just putting witness marks and going back and forth with it. You can already see why this right side piece took the longest time to make. And there at that point I probably final welded the tube to the lower plate. And again, and back, and forward. I'm probably doing 1 or 2 tacks and then pushing and pulling it around to make sure everything's still lined up. Every time I pull that piece out, walk away and come back, I'm doing another weld on it, another tack. Okay, there I'm showing I fully welded the lower plate to the upper tube, finally. Once again, we're confirming level and square. Okay, and now here you see there's an M10 boss on the on that side of the Tesla motor, and I'm actually making a brace from that M10 over to our mount. Without that brace, it seemed like the lever arm was just way too long on it. I didn't feel happy about it, so I figured I'd add another piece to it to brace it. And then I put some gussets from the bushing tube to the 1-inch chromoly tube that heads down to the plate. This is where I said screw it and finally pulled the welder over to the clip. Now I used to have like a 25-foot lead on the TIG, and when I went to this newer lightweight lead, I think I only bought a 10-foot, so it doesn't, the lead isn't super long, it doesn't reach everywhere now, but it's so much more convenient to weld with, so much more flexible. So I just dragged the whole welding unit closer to it so I could get over at the clip. I'm going to say, and just like that, I have tacked that piece on. Must be about to remove it so I can fully weld the entire piece. I will say that this is the first time I have attempted to do a voiceover on a video. I don't do a lot of video and editing, so I hope this comes out okay. Pulled it out. I assume at this point I'm going to fully weld that piece, bring it back, and call these 3 mounts done. Oh, there it is. Probably check it again for squareness and level. And I certainly did. And that's a wrap. Bam! And just like that, the mounts are done. As you can see, we have a 3-mount system. This will be the front, rear, and right-hand side. I'm actually standing in what would be the cabin of an MR2. It's my understanding Tesla is only a 3-mount this P100D. I think they call it the large drive unit of a Model S. Only 3 mounts. This side here is the inverter. This is just an aluminum. This is like some sort of just a thin aluminum cover with an end cap. There's no mounting on this side. This side is actually a welded casement with an end cap, and the Tesla mount just uses 3 M8s on this side. I've actually braced it from an M10 up to the top here and then put some gussets into the mount. These mounts are all 1/4 inch front and back. In testing, if it looks like this mount's trying to pull itself up from the bulkhead of the SW20, we'll put some sort of bars to tie it up here into the upper strut mounts. Beyond that, that's it. Mounting, all mounted, no cutting. The height looks good. I'll take the camera down off of the tripod here in a moment and walk around and show you how it looks from other views. All the electronics, batteries, electrical work, that's all going to be handled in Georgia, 3 hours from here. Those guys at XS Motorsports, XV Racing, Invoke Design, and Fuel Tech, they're all going to handle, as I said, the batteries and the electronics, electrical portion of this. My job is, say, the mounts, suspension, control arms, toe links, if they want to put a cage in the car, any other structural bracing we'll need to do to make this package work. Probably battery trays. They talked about building some sort of a tray to put across here to put more batteries in this section. Batteries in what here would be the fuel tank tunnel. Batteries in the trunk, batteries in the frunk. So lots of areas to put batteries. No, I have no idea what batteries they're going to use at this point. They have lots of options and configurations. Let me get the camera down and I'll show you the car. Should I say show you the bay? All right. Look how good that looks in there. Walk you to the other side. Too cool. I say from this point here, I'll take these mounts out. I'm going to build fixtures to reproduce them. And those guys will come here this week sometime, pick all this up for me, and start to build the actual car that they're going to be putting all the batteries in. Thanks everybody for watching. We certainly appreciate it. Be sure to subscribe to our channel and the other guys' channels that I've mentioned down below. And thanks for watching.